Hi guys, and welcome to the fourth Genome2D Devcast. I know it's been some time since I recorded Devcast. There were a lot of changes, but the Genome2D is still going strong. So let's look what I prepared for you today. We are going to talk about a new GitHub structure. I changed a lot of stuff because quite a few of you were asking me how to build the Swig file and how to work with the hexes sources and so on, and it was kind of a mess. Even though I recorded a video how to set it up, the setup structure to work with it was quite different from the actual GitHub structure, and there were a lot of different repositories, so I merged it and used submodules, and I will show you how to set it up very easily now. I'm also going to talk about the new version, which is a 1.1, and how I refactored some of the stuff there, mainly just renaming of factories and changes like that. There will be other changes coming as the API is going more mature, so I'm also looking for a feedback. If you have any ideas how to improve stuff, I'm all for it. I'm using Genome in my professional life as well, so there are a lot of stuff that came up when I work on a project that I'm working during weekends to improve in Genome2D. It's not the project that it's just developed to for other people to use. It's also for my real usage, so that's why it will go strong, because I have no reason to abandon it and use something else for now, and I don't see any foreseeable future that it will change. Anyway, and finally we are going to talk about the UI that is coming with the 1.1 version. It will be the first part because the UI is there is a lot of stuff to explain, and also there is some kind of tooling that I'm working on that I will introduce in the second part, and I'm definitely looking forward to any feedback when it comes to the UI, because it's a major part, and I don't want it to be too chaotic. And there is I came to a conclusion during these last months that there is no single way to make a perfect UI framework. There's definitely more ways how to do it, and one can't tell that this is the wrong way and this is the good way. There is a good way for a specific use case, and there is a wrong way for a specific use case, but there is a no single good way to make a universal UI. So I'm all ears about any features that you guys come up with. So let's start. First, I'm going to talk about the GitHub changes. So this is the main repository, or no, that's the core. It was the repository for the ActionScript version. Later it was deleted as the ActionScript version sources became obsolete, and there was just this introduction to the genome and links to all the other repositories. So now I decided to link all the other repositories, which are just parts of the whole library, as submodules to this main repository. So if you click on this, that's the submodule for the abstract common classes and the context for Flash and so on. So now you can just work with this repo and don't really think what are the other repositories. And there is also the binary folder for the library was moved from the core, and there was a bin folder here, and I move it to this main repository. So all of you guys that are just interested in the Swig file, you can find it here. This is the latest Swig, which I built like 12 minutes ago, and it will change probably daily. and there is also this stable for the 1.0 version, which I will also add the 1.1 version when it's stable enough, and I will not remove the 1.0 version even there, because I don't see a reason for that. But if you want to work with the stable version, I'll definitely suggest to use the 1.0 version. Although the 1.1 is pretty stable even now, but I just don't want to push it too strong. It's so stable, to tell you the truth, that even my main project was moved to 1.1 version this week. So except the UI stuff and all of that, which is stable, but I'm still working on the API in my refactor. So if you are going to work with the UI, expect a little changes here and there, especially from your feedback guys. But you can use it. But if you are familiar with the 1.0 and you are perfectly okay with all the functionality, I wouldn't suggest to move to the 1.1 yet. If you are unfamiliar with Genome2D at all, you are free to use the 1.1, or if you really need the UI and stuff like that. So let's work with this, and I'll show you how to build the genome yourself if you just want to build the Swig file, or if you want to work with the hexi examples. So we have this empty directory for our devcast, and now we will clone the GitHub repository for the Genome2D. We need to add this recursive argument here, because if we don't do that, all the submodules will not be recursively cloned as well. You will only get the directories, but they will be empty. So that's what that attribute means. github.com positive and Genome2D. Okay, it's now cloning our repo. It will take a while. I found out that all the tooling, like the graphical interface for GitHub and all that stuff, doesn't really work with the submodules, and it will fight and it will throw you like there are no changes, because those changes are actually in the submodules, and it can't recursively fetch the changes and all that stuff. It's a mess. So the GitHub shell is pretty much the best choice. Okay, we now have our Genome2D directory, and there are these build files. So if we have hexi, as you can see, I have hexi and 3.2, but you can use the 3.3 as the 3.1.3 as well, but there are some changes to the Flash API, for example, the multiple render targets and all that stuff that isn't implemented in 3.1 yet. So now if we have hexi, we can just call build swig hxml, and it will build it. So as you can see, I just build this swig file right now. So you are pretty free to, if you are familiar with hexi, or even if not, because hexi is very similar to ActionScript. So if you just find a little bit tweak and here and there, and if you just want to trace something, you can change the sources, build it a swig file yourself, and just work with that. Of course, the trace functionality will not work through Swig because it's a little bit complicated, so you would need to do a bit of other debugging, but we can talk about that in another devcast. What will this however will not work? For example, this will work, but this Swig file will not work because it's using eagle. As a lot of you encountered this problem, if it's using eagle inside the build file for the flash target, but uh, hexi has this problem that it will not include the the linkages in the catalog file for this Swig file. So you can either manually edit the catalog file and add the Eagle mini assembler stuff there, which I am doing each time I build a new Swig file, or you can include the Eagle Swig file to your project as well, which I will probably do from now on. So I will add this Eagle Swig file to the bin directory as well. So you will need to use the Genome2D and Eagle together, unless you want to edit the catalog files, because the Eagle Swig is built inside this Swig file, but it's just not generated in the catalog, because Hexi doesn't do that for external Swig files used during Swig file compilation inside Hexi. We can also build the examples as well, or the documentation, which I'm not going to right now. And the examples are, they have their own bin file, and as you can see, I just build the example Swig file, and it will run. It's the example number 1, I think, just sprites. I will also refactor these directories a little bit more. Just for example, clean this up. There is this bunny that I'm not using, and also set up the ActionScript project to build the ActionScript examples to build into this same bin file as the Hexi, or maybe I will move the example bin file up as well. But I don't think that's a good move, because the example repository can be used standalone, especially if you have the library for the ActionScript examples. We'll see. Those will be just minor changes. But as you can see, I set up all of my build files to work with the new structure. It just works with the exact GitHub repository names, no more like common core and stuff like that. That was working for my IntelliJ project, but for all of you that were just cloning the repositories, it was a mess. You can also work with it inside IntelliJ easily. I just created a Genome2D IntelliJ project, cloned the Genome2D repository here, and what I did was create a run file for Hexi application, and I told it to run. Okay, we need to change this. I just tell it to run the SVF file inside the examples. You can build it pretty much anywhere, but this is where it will build using the examples HXML. So if I run this, I'm not sure I'm set up to run this stuff. Oh, this is a mess. Anyway, so as I can see, it's set up to, I don't know why it's capitalized, but anyway, examples. So now this will build the Flash HXML, which will run, and now we are using Hexi to build examples, and you can trace directly inside the Genome2D framework code, and it works. So that would be all for the new GitHub structure and how to set up Genome2D. I hope you enjoyed it. And now I'm going to talk about the new refactor stuff and the first part of the UI. We can actually merge these two talks, as I'm going to show you the UI. This is a simple project, ActionScript project using the latest Swig file, and as you can see, Eagle is here as well. I'm just using these two together instead of modifying the catalog file. We are going to initialize the Genome2D, pretty much standard stuff, didn't change anything there. And now we are going to load some assets for our UI stuff. And as you can see, this changed from the previous version. Asset Manager is now a singleton as well, or more specifically is a static class. It's not a singleton. Instead of creating an instance for the Asset Manager, you are going to call the static methods directly. And you don't need to specify the ID for the asset loaded. You can, as you can see, but if you don't specify the ID, this will be used and as an ID sorry as an ID for the asset loaded. So we are going to load some buttons here and the font Atlas, and now we are going to call the load queue method, which will load all the unloaded assets edit in a queue, and call this callback where once it's done. So if we loaded all these 5 stuff and want just load another assets, we can call all the add or another assets and call the load queue that will load just the queued assets as well. If we are going to if we want to trace some kind of error, which is a pretty common, and as you can see, there is only one callback specified here for once it's done. But what if this asset doesn't exist? We simply add the signal callback, and it will throw an error and which asset threw an error and what was the reason for that error. Anyway, these assets are there, so this will definitely work. And now this is a new method for an asset manager that wasn't there in a previous version. What this will do is create textures from our loaded assets. So no more texture factories if we don't want to. And it will create the textures for this, and IDs used will be these. So the name of the asset, the full native path actually for the asset. And we can again specify the ID and create it using the old methods I'm going to show you. But if we just want to create textures from all these assets that we loaded, we don't need to do that per the asset as well. And you may be asking, what about this? This is actually one texture, or to be more precise, is a font texture Atlas that will use these 2 assets. And I'll tell you that it will detect it, since these are the same IDs, but just the extension is different. It will automatically think that this is a texture font Atlas. It is using FNT extension. If it was XML extension, it would think that it's just the texture Atlas, not the font Atlas. It's just texture Atlas. So it will work with texture atlases as well. You can also specify a scale factor to be used to generate these textures. But we are not going to work with the scale factor, so the default is 1. And as I told you, we can do this manually. So if we didn't use this, we would need to use the factories. There are no more texture factories inside Genome2D. I just merged it. Actually, I just moved a lot of the code from gtexture and gcontext texture as well. To tell you the truth, the textures and texture factories and all that stuff was the major refactor in the 1.1 version. A lot of source management was changed Since there were a lot of updates from the Flash Player team that introduced, for example, the rectangle textures, the different approach to render texture now, and even the not so new changes, for example, the new ATF files and stuff. So, and it was an incremental change to all the Genome2D texture, and there was kind of a mess. So I took all the changes, removed all the old source code and created it from scratch. I was just looking at it as, okay, now we have all this new stuff, and build it as clean as possible without thinking about the old code and how it was hacked into it. So of course I just tried to mimic the old API as much as possible, but as I did this, I decided to remove all the factories, because it was unnecessary bloat. And if you wanted to create atlas, there was a different factory, and if you wanted to look up for an atlas, there was a different method. So now I created this single static class. It's called texture manager, and it's used for all the creation of textures, and it's used for all the lookup for the textures. So now if we wanted to create, as you can see, a lot of methods. So now we want to create the texture for the asset button 1. So we are going to create texture, and as you can see, a new method as well. We can create it from the asset instance. Since we don't have the asset instance, we can now create it from the asset ID as well. And we have the ID, since the ID is the name of the file. So what we need is specify the ID for the texture. Let's say button 01. I am thinking about moving this past the image asset ID and making it optional. So if you don't specify it, it will be the same as this image asset ID. So this is a possible change in the near future, but we'll see. Now we'll specify the ID for the asset, and again there is the scale factor and repeatable and format stuff, which we can specify as well, or we can change it on the texture instance. So now this is what would be texture factory create from asset, and we would need to do a lookup for the G asset manager, get asset by ID stuff. So it's smaller, it's less verbose now. And again, let's say we want to look for our button 1 texture. In the old API you would do the G texture get the get texture by ID. Now it's all the lookup is inside the manager, and we want the get texture by ID button 01 will return our texture instance. So this is a breaking change. It's not much of a change. When I was refactoring my old project to the 1.1 version, it was just about the renaming of the stuff. Instead of G-texture factory and G-texture get texture, you always use the G-texture manager. Now back to our example, and let's show you some UI stuff. There is a new component. It's a single component, and it's a GUI component. Yes, it's a single one, and I will tell you why. So let's create a node with that component. Again, as you can see, no factory. There is no gnode factory. Since that gnode factory was except one of the first versions was always used to create a gnode, I decided to remove it and move that functionality to the gnode itself, so we can just create an empty gnode or from prototype or create with component. That's what we want to do. So we are going to create a GUI component, and what this is, it will create it's very similar to Unity actually. It's a component that will do just the GUI rendering. It doesn't involve any nodes inside itself, so all the other UI elements are not managed by nodes unnecessarily. So it's a very specific approach to it's a closed UI hierarchy inside this component. It's not another nodes inside this component. It's just used to render a specific UI. You can have multiple UI components, and each of them rendering different UI if you want to. So, for example, a top menu may be a different UI or component than the bottom menu. You can also have both menus inside the UI. So it's up to you. It's it's a better manageable than if it was a specific each node had a, for example, a button, and a container was a node and stuff like that. Now if you are working on the UI, you know you are working on the UI, and there is a specific hierarchy used for that. So this UI will just render but nothing basically, because we don't have anything. What we need to do to set the bounds for this UI, very similar to Unity as well. So there is a root element for the GUI, and we will set this root element to have a world rectangle 0 0 and stage. So we are going to tell this node that it's basically going to render on the whole screen. The node transformations are not taken into account for the GUI rendering. So if you have a specific UI rendering on the node and the node moves, the GUI will not move with it. So if you want to animate it, you should do it inside the GUI hierarchy. Again, this is not set in stone yet. This is work in progress, as I want to hear a lot of feedback and how you guys find the API. Also, this is very clumsy. I will probably move this setdirect to the UI component directly, and even do some kind of default setdirect on it for the whole screen, or at least the context, because the context may be different from the stage. Anyway, now this tells the GUI component that it should render on the whole screen, and we need some kind of stuff there. So what we need is an element. There is only a single class for rendering, similar to the node. There is only one node in the hierarchy, and that's the element, GUI element. So we are going to create a GUI element and add it to our root. So now we have an element there, and if we run it, surprise, surprise, there is nothing there. Why? Because element, very similar to node, doesn't do anything. It's just a positional and hierarchical stuff. So what we need for a GUI is a skin, and we are going to use the texture skin. We are going to tell it a skin can have an ID, so you can, there is a skin manager, and you can, it will automatically, if I specify this ID, for example button 01, and let's specify a texture ID we are going to use to render this skin, and that's the button 01 JPEG. It will automatically add, similar to texture, to inside some kind of skin manager, and you can look up for this skin. Now when we have a skin, we can add it to the element. For now there is just a normal skin, but there will be probably few like over skin and stuff like that, or I will maybe even do a hash map lookup, so you can define a group of skins on an element and change it. Let's tell it that now it should render this skin. Again, not set in stone, but this is how it works now. So there is a normal skin, and we can set the instance for the skin. Again, we can say use the normal skin ID. There is a lot of ID stuff inside Genome2D, and it's transparent to the user. Actually, this is used by professional 3D engine and even in Unity as well, but it's not just transparent. Because if you want to save stuff to the disk, for example, or for some kind of scene hierarchy or a prototype, if you are familiar with prototypes inside Genome2D, you can't actually save skin instance. You could, but every time it's referred, you would do all the data or serialization of that. So if you want to save this to a disk or into a somewhere else, for example, some script or stuff, all these IDs that are transparent are pretty handy. Now, if you enumerate your elements and want to recreate the graph, that's what the internal Genome2D prototype is using, you are free to do using the IDs. That's why everything in Genome2D is ID connected, not just by references. It's pretty much also it's kind of safe because there is no skin without an ID, and there can't be two skins with the same ID, so you can at all times inside Genome2D know about all textures, all skins, all assets, if you just iterate all the IDs. So you are pretty much safe there. There are no lost references floating around. Now, since we set the skin to the element, we should render it and see something. Oh, we don't see anything. Why we don't see anything? Silly mistake. We didn't add the GUI node to the render graph, obviously, of the Genome2D. So this is pretty basic stuff for all of you that use the Genome2D. Since we created a node with the GUI component, we need to add it to the scene. Now we should see our skin, hopefully. And as you can see, our button skin, it's a free button template from internet I found, and it's in the middle of the screen. If we set up the GUI route to somewhere different, it would be in the middle of that area. Why it is in the middle? Now this is the interesting part. There are a lot of properties for the element, how to position the element, and there is this default values that tell it to be inside in the middle of the screen, and that is anchor. If you are familiar with Unity, especially the new Unity 4.6 and its UI, this is spot on. It's inspired, although not exactly, it's inspired by the Unity rendering of the UI. I actually was working on it even before the 4.6 came, but not going to lie, I was inspired by a few stuff they did there. Amazing job. Although they're overcomplicated in some areas, so I kind of decided to go a different route. But it's very similar. So if you check out Unity, it's spot on. So these four, anchor, bottom, left, right, and top, tell us where this anchor, from which we are going to specify the position of the actual element, where this anchor is inside the parent element. So the anchor tells us it's relative to the parent, not to the element we are specifying it, and it's normalized value. So now all these values are 0.5. So since it's a normalized value, and the parent is the root, which is specified to render on the whole screen. So the anchor bottom is 0.5, anchor top is 0.5, anchor left is 0.5, anchor right. So it's in the middle of the screen, and the element is rendered, since its pivot is specified on the 0.5 as well, which is a different property. It will render in the top, in the middle. So if we for example change the element anchor left to dot 2 and element, for now we can specify a different value, but for now element anchor right for the 2 as well. Again, this is a normalized value from the top left. So anchor dot right dot 2 is not from the right dot 2, is from top left. So it's both are at the same position. It will be in the fifth of the parent 1/5 of the parent rectangle. And if the parent rectangle changed, this will scale. It will always. So now the parent rectangle is like 400 pixels. If it was, so 1/5 of the 400 pixels is 80 pixels. So it is here. If it was for example 1000 pixels, if we rescaled it, now we can't because this is not scalable. We didn't specify scalability for Genome. So if it was 1000 pixels, the normalized value would be 200 pixels. So this would move, and it's very handy for fluid layouts for games especially and stuff like that. So it will nicely scale with content. Okay, now we are saying now that for example what if we don't want to scale it relatively to the parent. So what if we always want it to be 80 pixels from the left, even if we scale it to the 1000 pixels? Very easy. We will tell it to be at the absolute left, which is 0 is always 0. Now, no matter if we have 1000 pixels or 400 pixels. So now, as you can see, it's going to render on the left, and doesn't matter if we scale it or not. 0 is always 0. So now we have the relative position, and we will add absolute position. So this anchor X and anchor Y tells the relative position, which is calculated after this. So now we have this anchor position, which is calculated from the real world space coordinates of the parent element. So now this is, since this is 0 0, the coordinates will be always 0 0. And now we have these absolute positions which will be added after this is calculated. So if it's 0, it will add the 80 pixels, and it will always be 80 pixels. So this is definitely not 400 pixels. It is a different position that we saw if we specify the 0.2 value. Anyway, this is now 80 pixels. Now, what if we specify the anchor right and anchor left differently? Like, it can't be at the two places at once. Again, if you're not familiar with Unity, it will do the same thing. What it will do, if we render it, it will scale our element. So this now tells our element that it should be at the 0 0, because 0 is the anchor left, from that value to a specific value, which is at the absolute right of the parent element. And this is very handy. If we scale it, it will scale with the parent element and stuff like that. So if we specify this like 0 9, it will relatively, so there will be 1/10 of the parent width gap, then our element, and again, since from the right there is also 1/10 missing, since this is an dot 9 from the left, so 1/10 is missing. It will scale there nicely. Now, and this is a little bit of a mess on the Unity front, and again on the Genome2D front, because it can't be actually, I don't know how to say it. It's unclear from the API standpoint. Now the anchor X and anchor Y will do nothing. They will do nothing because for the anchor X will do nothing, because this is hard coded, and you can't. What would this specify? It would specify from left or from right. So would it specify the position for, let it compile, for this or for this or for both? So for both, if I specify 50, both should move 50 that way, 50 to the right, or what, or 50 to the left. So it was unclear. So that property is obsolete if you don't have the anchor left and anchor right values at the same value. So if anchor left and anchor right is different, the anchor X property will be obsolete and not used. There is, however, different property that is used in this case, and that's the element left and right. And very similar to the anchor X. What if we don't want this to scale relatively? What if we always want, let's say, 50 pixels from the left? Doesn't matter how big the parent is. Okay, I should specify this one. Left is not used if we specify 0, 0. It wasn't. So what it does, again, left is on the, now the anchor is here, so it's actually scaled from that, but we specified an absolute value for the left to move. And since we didn't specify any right, the right part is there. So as you can see, this is very, very powerful. You have the relative positioning and absolute positioning at your fingertips. So you can pretty much do anything here, and it's absolutely fluid. If you rescale it and you are using the relative stuff, it will rescale. You can also combine, so you can say that it should be 1/10 from the left, and so this will tell us the anchor is here, and it will also use an absolute value as well. So it will be here, anchor plus the absolute value we specified. So it's very powerful. There is pretty much all scenarios covered. You are not missing anything at all. And since we just got over the 40 minutes mark, I'm going to end our talk today here, and in next part I'm going to hopefully introduce some kind of tooling, or at least how I see tooling for this, and I'm going to talk about layouts, because sometimes we want to tell the parent element that it should organize the children elements for us, for example a list or a grid, where we don't want to specify all these values for our elements. And we are going also to talk about font skin and other skins, and we are going to talk about 9 slicing. The genome now actually supports all kind of slicing, from 1 to 9 slicing. You can have 7 slides, you can have any number of slides. It's very intuitive, and I will show you, and it's very nice with the tooling, where you can specify it. You can specify the slices and how they should scale, if it should scale or if it should tile scale, and all that stuff. And if there is time, I will also talk about prototypes and how you can manage this from XML. So you will be able to just have an XML looking structure and just by editing that you will completely change your UI. So if you have some kind of HTML programmers around, or even graphics, and they want to play with the UI, they can just edit a simple XML and invalidate the example that will I may build for you, or you can build yourself. That will just need to invalidate the prototype, and the UI will completely change to the new XML, and it's very handy inside, instead of just writing all this stuff. If you can have all this inside a single XML line. So thank you guys, and I'm going to finish now, and looking forward to your feedback. So cheers.